Hello, everyone. As been said, my name is Odong. I come all the way from Uganda, and I'm here to present my prototype that we've been working for the last 6 months. We've been learning a lot from the academy, and I think I'm here to present the fruits of the academy. I'm delighted to be one of the members of the academy, and all goes back to our tutors for training us and taking us through all that long until we managed to come up with something. Mine is very simple. I'm designing a mini biogas plant for household use. And briefly, to go on my background, you realize Uganda has a lot of power actually, which comes from renewable energy, but most of it is hydropower. And this power, in Uganda also there is a lot of, the population currently is shooting up to 45 million people, and this has caused an energy poverty, energy scarcity. So most of the resources have been used, and this has brought in pressure for energy. So we realize this pressure has also mounted in rural areas where most of the material used in rural areas is biomass in terms of biofuel like firewood and all that. So all this comes back, and we realize that also the pressure that has been put on the natural resources like trees has also increased global warming, and this is due to deforestation and all that. So all this comes back to biogas. Having an alternative fuel will therefore be a great change for the world, and biogas is one of the things which is not new in Uganda as well. So if this is brought in, it will help a lot of people. And my target group is majorly the women in rural areas. Realize firewood is really a very significant material for small scale like bricklaying and all that, but majorly in rural areas it's used for household use, majorly for cooking and lighting. So realize even collecting this material is becoming, it's very tedious, and mostly this work is done by women, as you can see in the picture. And this has deterred women from social economic activities for their own development and all that. So after all the brainstorming we did, we decided to come up with one idea, because given the strategic location of the place, decided to come up with an idea of biogas. And then our case study is actually in Uganda, in a certain district called Bukedia district, but we're concentrating on the village called Malera. And then the roadmap to achieve the design of my biogas, I had to first conduct a feasibility study. Then later on, using the results of the feasibility study, I had to develop a design which can accommodate what I've found on the feasibility study. Then later on, I will do the construction. Results and discussion. We looked at the sample space. We're dealing with, we did 10 households in 3 villages. And then the interviews we're conducting, we interviewed both male and female. This goes back to my problem statement. If you can see the way I've trended here, the line for men, the green line, realize men are not at home at all. So it is always women who are at home. This is the green line. It's always higher, because I realize the most in our sample space, the people who are affected are majorly women. So in our feasibility studies, we checked on the cooking fuel used. This is 99% of the fuel used here is firewood, and then 1% is there in for kerosene, electricity, and gas, which you don't even see sometimes. And then if you look at the fuel for lighting, the bigger percentage is always paraffin, that is kerosene, that is used for lighting. And realize also this emits a lot of gases and all that, which are harmful to human beings. Electricity is majorly comes in when they're using the solar panels, most of the solar lights and all that. That's why it has a bigger. And then you have firewood. Firewood also here. Firewood is also used for lighting sometimes, and then other resources. Then commercially, let me go back. Commercially, most you realize that wood is sold also highly, and then paraffin. So these are the energy sources that are majorly used in the villages. Gas is nowhere to be seen. So in our feasibility studies, we checked on awareness. How do people know, how much people know about biogas, the attitude, which moral do they have towards biogas. Then we also checked on the household income. Realized daily income for a household can be $1.32. That's around 5,000 Ugandan shillings daily income, and most of this is gotten from the small, like maybe someone hires you to go and weed somewhere or help him in the garden work and pays you. Then we also checked on the assessment of the availability of the resources that you can use for making biogas. Realized water is readily available because water helps you in hydrolysis during the formation of methane. So water is readily available in the community because the government constructed, provided people with boreholes and all that. There are spring wells all over. Then we checked on the livestock for the feed, for the cow dung that we might need. It's also readily available. So now we go to the design. The design, the average number of cows per household was around 8 that we needed for our design. And then each cow can produce around 10 kilograms. You realize that the reason why they produce 10 kilograms is because most of these cows move long distances for pasture and all that. So they come back home just for a night, and then so if you have 8 cows, you can produce around 80 kilograms. Then we go to our gas requirements. We want gas for cooking and lighting. One gas for cooking and lighting. So gas for cooking, we needed 1.32 chumex, and then gas for lighting we needed around 1.13 chumex. So getting all that, we got the total of the gas that we needed. We needed 2.5 meters cubed. So after getting our gas requirement, that was 2.5. We narrowed down to the design of which type of digester that we used was supposed to. Then we came up with a fixed dome type because of its technical and financial capabilities. You look at its gas storage, it's maximum, but we don't need this maximum. It can go up to 20 meters cubed. Then the gas pressure and all that. Then availability of the material, this is what we checked around. Exactly, the material is always available. And then it's also agitation, self-agitated by the biogas pressure. And then the methane production is high. Then we had to determine the volume of the digester. The volume of the digester is given by this question, and we got this from a flow tower that is Raya 2000. This is where we got this. But the volume of the digester is given by volume of the fluid times the rotation time. the rotation time, the time that is spent in the digester, the time the feed stock is spent in the digester. So this is how you find the volume of the digester. So after getting the volume of the digester, which was around 5.45 meters cubed, we needed the actual digester. We needed to accommodate also gas disengagement. You know, when the process of hydrolysis is done, there's gas produced and all that. So we need that clearance for the gas disengagement. So for our design, we had to get the actual volume, which is V, which is called times, we added that 5.4, we added another 10% higher so that we can get the clearance for the gas. So the exact volume that we wanted for our design is 6 meters cubed. Then also I had to get the dimensions, the diameter, and the height. Then I come to the most interesting part, that is my conclusion. We need around 2,000 to 2,500 and about 6 to 4 cows to generate biogas for around 8 people, which can last for 20 years. I think that is economically very good. Then a fixed dome plant was selected because of its low cost and cheap technology. Then that was our digester volume, as I told you. And the economic activity here, I realized it is cattle keeping and then subsistence farming. The situation on the ground literally requires biogas for cooking and lighting. Then the recommendations: biogas being cheap, reliable, and easy to construct can be sustainable, and such is necessary technology that needs to be exploited for the benefits of the rural community. And there is need to sensitize and educate people about the use of biogas. Actually, this is where we shall need a lot of benchmarking, teach people a lot of how to use and maintain their biogas. Government should come in and support the biogas project. Need to create technical jobs for people that will manage the plant. Then future plans is funding, at least for a pilot biogas project. If I can get funds and put this in that village, I think it will be a motivation for the rest of the people to come up with the biogas plant for. Then my other future plan that I eagerly want is I want to study a lot in renewable energy, because we're in the state of energy transition, and we need a lot of experts that can help us make technical decisions during this transition. And also back at home here, I want to do a water weed harvesting for biomass fuels to optimize production of hydropower. Here in Uganda, we have water weed, which comes from the reservoir. And this weed always brings in, comes with a lot of silt, a lot of grass, a lot of all those, so this end up blocking the trash racks and then the waterways. So this drops the head, and then the electricity generation is affected. So this is if we can harness or harvest this weed upstream and then put into use, like for biofuels, I think we shall be able to optimize hydropower production. And then I also want to be fully engaged in the course of energy transition. For that, I can say thank you. I remain Odong Sam. This in case you want contact me, you can reach me on my email, my number, and then I'm also on LinkedIn. Twitter, my handle is Big Sam at 4991. Thank you very much. I welcome your questions.